All right, how's it going, guys? Today is Tuesday, February 19th, 2019, and you are listening to the Slate Robotics podcast. This is our very first episode, and this is a podcast that is all about talking about robotics. It's a more technical podcast than I think is what is available on the market, the podcast market, so to speak. And this is going to be mostly talking about our products and talking about things that relate to us as a business. And I'll get into, if you're not familiar with who we are and who I am, I'll get into that in just a second. But again, this will be a bit more technical, where we'll get into different design elements, architecture, but it's not going to be anything. It's not going to be too much like jargon where you're probably going to get super lost if you don't have much exposure to robotics. So it's for people that are interested in learning the technical elements of robotics, and we'll talk about a lot of different things. What the kinds of things we won't get into is like the political questions, the like doomsday kind of I don't know, the doomsday stuff that people peddle today. We won't get into that kind of stuff because I think those kinds of debates are frankly just kind of boring, and I'm just kind of bored of people talking about them already. So, again, my name's Zach. Actually, I don't think I said my name. My name is Zach, and I am the founder and CEO of Slate Robotics, right there. And what we're doing is we are building human-sized robots for hackers, and we're trying to make large-scale, human environment working robots more affordable. So these are, anywhere from 4 to 5 feet tall robots with an arm, and it's capable of working within a human environment, and it's at a price point that people can afford. So our product that we have on the market today is the Tr2, which sits just under 4 feet tall. It has a big arm that's capable of performing some really great work. And it has a mobile base, so it's able to move around within homes, and there's a lot of other features, and I could spend a long time talking about that. But check out our website if that's something that interests you. For people that have been following us for a while, you might be wondering where we are as a company. I don't update too much. I don't really give updates too much to non-customers. So I think this is a great opportunity for people just to know where we are and what's going on, and for anybody that's interested in following us. So we launched the TR1, our first robot, last year, towards the end of the year. I think it was in August, and it was a good learning experience, I'll say that. That was a very difficult robot to fulfill orders wise. We got a handful out the door, and we got them to customers. We were able to get some feedback, and we were able to work with those customers and improve the design of the we were able to take all of that feedback and put it into the new design for TR2, and take all those lessons learned with what was easy, what was good about designing and manufacturing TR1, and what needed improvement. So that was a great, invaluable learning experience. And then, so where we are today, I mean, I've got TR2's design completed, and I've got the prototype completed, and now I'm just building my first production version. Good full clean version that we can use for a demo video, and then I can start sending out robots to customers. So that should be in a couple weeks. But how these things go, I might decide that I want to redo the communication throughout the robot, the network topology. I might want to redo that. And that might kick it back, another month or two. But right now, where I'm focused at with the business is just doing everything I can to make existing customers happy. That's the main thing I'm focusing on, and making sure the design is perfect. because the capabilities of the TR2 are so much further beyond what TR1 was capable of. I know without a doubt if I can make this robot good enough, there's going to be a huge market of people that are going to want to buy it. And part of the market that we couldn't address with TR1 was the manufacturing, kind of pick and place kind of tasks. It wasn't built for that. It was just kind of for people that wanted to explore the robotic space per se. And it wasn't really for anything useful. But TR2 very well could be. So we'll see, and stay tuned for that. I'm pretty excited about where we are with that. I mean, it is a groundbreaking product, and most of the information is available on our website if people are interested in looking that up. You can also so all the information on our website. What I was going to say is that we'll have a demo video, which is really what people are interested in. We'll have that up at some point soon, but I can't make any promises to that. I'm learning things about myself where in the past I would make promises about that and then not keep the promises. So I'm learning to just not even make the promise at all in the first place, which I think is better off. Honesty is a good policy. Okay, so that's where we are with the company. So let me talk. So we'll talk about 3 things today. I want to get into a little bit with the new Tr2 Arm Design, and I want to talk about that. I've got, for anybody that's watching, I've got an arm that I'm going to bring up and show you guys. It's just half the arm. I want to talk about some of the hardware elements of it. And then we'll talk about kind of a futurism question, which is, how much do we think robots are going to cost in the future? I think this is like the most important question that nobody's asking. Like I haven't seen anybody ask this question. How much are robots in the future going to cost? Everybody talks about what they're going to do, what they'll look like, what the capabilities will be, but it's rarely what's it going to cost. Is it $100? Is it $100,000? And then we'll talk about, if we have time, I want to get into talking about omnidirectional wheels. I saw a question on Reddit asking about omnidirectional wheels, so I have some experience working with that, and I have some different things that can help you if you're building a robot for something like that. It's just kind of interesting bits of hardware. So new arm design. Let me grab this. Boom, boom. Again, if you've seen on our website, we have the 3D rendering of the robot up and available right now. So this isn't new. This isn't something you wouldn't have been able to see before. But this is the first time I've shown this on video of the actual hardware. Again, this is just a prototype, so you can see it's all printed in natural ABS plastic. Okay, tape on here that describes the bus address of each of these actuators. It makes it easier for developing. Obviously, the production version will be painted and post-processed and cleaned and all that kind of stuff. So with TR1, let's talk about that arm design, and then I'll get into why this arm design is much better. With TR1, I had designed that in my garage over a course of a couple months. And as the first robot I really ever designed, and it was the first robotic arm, certainly, that I ever designed. And I kind of started with what I wanted it to look like first. I tried to conceptualize, okay, what is this thing going to look like? And then I figured out, where am I going to put the motors? Where am I going to put the sensors? Where am I going to, run the wires? That was all after the fact. So, the wires are a good example. There was no thought prior to designing that robot where the wires were going to go. It's like, oh, well, I'll just kind of get to that when I get to it. Which, first of all, that is a strategy that works. uh, hey, the robot functioned, and it was still a groundbreaking product for what it was. I mean, it was, nobody had built a robot that affordable before. But because I didn't think about where the wires were going to go, well, okay, you get to the point where it's time to assemble it, it's time to put the motors in, sensors, where do you run the wires? So it just, everything ran out the side of the arm. And, I wasn't able to keep the wires within the housing of the arm, like within the actual plastic shell. They had to be run on the outside. And that has various downsides. I mean, first and foremost, it just doesn't look good. And secondly, wires get in the way whenever you're trying to work on stuff with the robot. So that was a downside. Now, you'll notice with this arm, there are no wires on the outside. The wires run through the center of the actuator. So this is a full actuator right here. Runs through the center, out into this plastic housing, through the center of this, and then into the gripper and all that kind of stuff, right? So the wires were designed prior, like I had thought prior to designing this arm, where are we going to run the wires, and how can we design this so that I don't have to worry about wires getting tangled. I don't have to worry about things getting caught. So what I've done with this actuator is there's actually a steel tube. It's a 1/2-inch steel tube that runs through the center of the actuator, right in the middle, right? And you can feed the wires through that center. And then that's great. And then you think, well, but if this thing rotates over and over again, like this could be a continuous joint, right? Where it's mounted here, and this part rotates and continuously rotates, right? Well, then the wires get all tangled up, and then it pulls the sockets out of the PCB in the back. Well, they make these things called slip rings, and slip rings are I've seen one video of someone taking it apart, but anyway, it's basically I think it's got these rings on the inside, and it just maintains electrical connection as it rotates. So you'll have wires on either side of it, and then as it rotates, it maintains those connections. And it's more than just plates rubbing against each other. It's a little bit else, but it's that way you can have wire going in here, and then you can have that slip ring out here. And as this joint rotates continuously, it maintains the connection, and it doesn't pull the wires out of the socket in the back. So that is a incredible difference just in having that past experience of designing a TR1 and taking that and putting it into the TR2. That's been incredibly valuable, because that's not something I would have thought of with my first robot, because I didn't have the experience of building these and playing with a robot that didn't have that kind of engineering foresight ahead of time. So then that means that on the inside of this body, this is the body of the actuator and then the head. And I apologize for anybody who's listening who's maybe having difficulty following along. But anyway, the motor and the encoder. So the motor there's an internal gear in this cap, and then there's a normal spur gear attached to the motor shaft, and those are all offset around the outside of the shaft. You would probably be inclined with something like this to put the motor directly in the center. Whenever you do that, you can't run the wires through. That's the axis of the actuator, and in order to keep the wires enclosed, you really need to run the wires through the axis, and that's the point of the steel tube. And it also, that's a great point, because I'm using that steel tube. I'm using bronze bushings, and I'm using shaft collars through here to keep this whole thing tight and assembled. That allows me to have a 3D printed arm. This thing is, it is beefy, right? This thing is super strong. Once we get everything ready and I get some customers' robots out the door, I'm going to take the Tr2 on the road so that I can show people physically, hey, hold this arm, and you'll feel exactly how strong this thing is. But by doing the steel shaft, bronze bushings, the shaft collar, having that be the actual axis of the actuator, that has allowed me to still have a 3D printed design, but keep it really strong. Because I can't manufacture just about anything other than 3D printing. I've got to use off-the-shelf components, and you're not going to find an off-the-shelf component for an actuator like this. So I have to 3D print this. I can't afford to manufacture it any other way. And you presumably could if you went out and you raised $500 million, but that's not something I'm really interested in doing at this point. But anyway, this design, I mean, that just shows you how far you can take 3D printing with the right design. People have criticized the TR1. There's a lot of things with TR1 that people criticize, and they were right. And that I thought they were wrong at the time, but I now know that they were right. But there's also some things where they criticized about the TR1. I thought they were wrong, and I still think they're wrong. And that is using a bunch of 3D printing. And this is still a lot of 3D printing by most people's standards. I mean, this is just 2 actuators. There's another 3 actuators for the rest of the arm. You can see the CAD rendering on our website, and it's still all 3D printed, but it's using ABS plastic. It's using a really great design that keeps everything strong and tight, using the steel shaft like I was talking about. There's 6 mount points all around the back face and the front face, and I'm using these special threaded screws to keep everything tight. And it threads really great into the plastic. So my whole point with that is, through a bit of trial and error, through a bit of lessons learned from past robots, and just proper design, I've been able to make really the world's best 3D printed arm. And I don't have any question about that at all. Again, a lot of people are still going to look at this and go, well, you can't use 3D printing. But the thing is, the point of the company is that we're building affordable robots. You could throw a bunch of money at the problem, but you wouldn't have done anything. I mean, people already are making expensive robots, but not a lot of people are making these kinds of robots at the price point that we're doing. And actually, nobody's doing that. There are robots in the price point, but not with arms like this. I mean, this is next level. Also, here's the gripper. So we've got a kind of rack and pinion setup here, where there's a servo motor with a gear with 2 pinions, and these fingers. You'll notice there's these screws on top, and that actually screws into the plates that slide through there that have the actual gears on it. So what that means is you can actually take the fingers off. You can unscrew them and screw something else back in, which makes that a really modular design. It also has a much higher quality servo motor than we had with TR1. With TR2, because we only have 1 arm, and that was, I decided that specifically because I've noticed whenever I was using the robot, it was really I was pretty much just 1 arm at a time. 2 arms were really too much for me to handle at any given time. And how to wrap my head around designing something for 2 arms, and I just never got there. So I thought, well, if I'm only using 1 arm, I would be better off just having more money to spend on higher quality components and parts for that 1 arm. So that's the kind of stuff that by having 1 arm, that's what it buys you. Is this is a Dynamixel AX12A. This is kind of the industry standard servo motors for robotics, and this thing's packed full of features. It's a really smart, intelligent servo, and before we were using cheap, what are they called, MG995 or something like that. Those like the $7 servos you buy off Amazon. They work fine, but they eventually burn up, and they weren't ideal. This way, we have more money to spend on the components, Each actuator has its own motor driver. It has its own microcontroller and onboard communication. The motor that we're using for these is a really high quality motor, planetary gearbox. It's got a huge gear reduction, but it outputs a ton of torque. These actuators, the motors themselves are rated, close to 50 Newton meters of torque, which if you know anything about motor, I spent months trying to find a decent motor for Tr1, and the best I could find was a 15 Newton meter torque motor. So this is over 3 times more torque, and then it's got a 3-to-1 gear reduction on top of that with the spur gear that goes on the motor, and then the internal gearing of that actuator cap. So now in theory, without a coefficient of friction, and without worrying about whether or not parts are going to break, that's in theory up to 150 Newton meters. Now in practice, it's not going to be that. And in practice, this is what I've done testing with, and again, it is 3D printed gears, so something's going to go wrong at some point. But 50 Newton meters, that's the testing that I've done internally. I've got a big long 2x4 with a eye hook on the end of it, and a bucket you can put weights in. We've weighed it out, and we know the length of the arm, and we've been able to run these actuators through their paces and improve the design, and that's been really valuable. We've been able to get up to 50 Newton meters with the actuators without much of a problem. So 50 Newton meters is what I'm sticking with, and what that means is even with this arm, which is pretty heavy, you'll be able to carry up to 2 kilograms of payload on this arm. The cordless drills that we have in here are 1.2 kilograms, I believe. So that gives you a bit of a reference. So you'd be able to hold almost twice what a cordless drill weighs, right? So you're still not going to be, picking up chairs. Well, I don't know, maybe the right kind of chair. You won't be like picking up tables or like moving furniture or anything like that, but you'll be able to pick up most things that this would be able to actually, grip or hold. So, dude, Tr2 Arm Design, very, very excited about that. And I've been working on that new design for, really 4 months, probably, which is incredible in its own right, because it took me over a year to get Tr1's design completed. So this was a much shorter time span for this. But anyway, that's just kind of because I know a little bit more about what I'm doing now. So that's that. And if you guys have any questions, email me, start a chat via our website, or just leave your questions in the comments. So next question, that was Tr2 Arm Design. Next question, how much are robots of the future going to cost? This is a question, again, I think there's not a lot of people asking this question. There's not a lot of people pondering this, but it's like the most important question. I said I wasn't going to get into the doom and gloom, robotics taking over. It's people have, anyway, I just think it's funny that people are really worried about robots taking their jobs. I'm just thinking, I'm thinking about the South Park episode of the rednecks running around saying, they took our jobs. And it used to be people were worried about immigrants coming in and taking our jobs. And now it's robots. But it's still the rednecks getting concerned about it. But this time, I guess it's people on the left too. All right. So how much are robots in the future going to cost? Well, this is really important to that question of are robots going to take over? Because if a robot costs, well, we'll say $100. We'll use an extreme example. If a humanoid, fully capable, fully autonomous, bipedal walking robot, that's just as capable of you or I in performing tasks. If that robot costs $100, then boy, this is a piece of technology that is going to disrupt the economy like you would never, like you would never have seen in the past. But if that robot, again, just as capable, and we'll pass this down into the future, who knows how long it would take to get here, or if it's even capable, or if it's even possible of building a robot like that. But if it cost $500,000, well, that kind of changes the consequences a lot, actually, because one example, $100, you don't need human labor at all whatsoever. There's no point for human labor other than just performing tasks that the robot can't do, is physically not capable of doing, or isn't able to do it quickly. But again, we've already assumed that this robot is as capable of humans. Well, if it's $500,000, are you going to spend $500,000 to have a janitor at your building, or you're going to spend $500,000 to hire a maid for your house and to pick up? No. And it would be $500,000 up front too. You'd have to acquire $500,000 of capital to hire a janitor. And that doesn't make any sense. What makes better sense is hiring a janitor for, your $10 to $15 an hour. Who knows what janitors can make? It might be more than that. But hire them for your $10, $15 an hour, and you don't need any cash up front, other than just the biweekly or bi-monthly or whatever payroll. I guess it would be bi-weekly. You got to run payroll 2 times a month, and you don't need $500,000 of cash up front in order to just go out and get a janitor. So that's an example of, just because robots could potentially be as capable as humans, and I think the jury's still out in terms of whether or not that's even possible. And I don't think people give that enough credit. But the cost question means everything in terms of what sort of impact personal robots of the future are going to have, and which is why Boston Dynamics, for example, they build incredible robots. Their demos are just shocking in terms of their performance, and I am so impressed by what they've got going on. But the reason they don't have any impact in our world outside of a cool viral video is because they're too expensive, and because they're not out to build an affordable platform. They're out to build the coolest, meanest, baddest thing that they can possibly manage. So by them neglecting the cost question, for better or worse, they have shrank the impact that their company can have on the world, which is why, I'm like, we're from Missouri, so we're like the redneck Boston Dynamics. That should be our new tagline. Maybe I should make some t-shirts with that. We're the redneck Boston Dynamics. Boston Dynamics has got, billions of dollars in capital that they've raised over the decades, and they throw a ton of money at that project. And, like us, a few grand, it's like, it's like walk into my garage, look around for some spare parts. I mean, that's literally how I started the company. The first design, before I knew anything about designing robots, I would literally walk around Lowe's and just try to find random scrap parts that I could use for the design and for the look of the robot, for different functional parts. Like, I had no idea what I was doing, but I didn't have the budget to just like go out and throw a bunch of money at the problem. So my wife and I literally walked around Lowe's for like an hour, just, I've got this different component and I need it to do this, and I don't know what to do. Maybe I could take this spring over here and I could use this bolt here, and, this different material over here, and I could combine that together. I used like, there's like this, that like kind of white textured, kind of rocky insulation paneling that they'll put, on the outside of refrigerators and stuff like that. I found that material and I thought, oh, okay, I'll use that as the cover for the robot. There are various reasons why that didn't work, but that was what, it was scrap parts. But that was because I personally had a low budget. And also, I knew that our customers were also going to have a low budget, so I needed to do that. Now, look, we're not as successful as Boston Dynamics are as far as value capitalization goes, or what? The value of the company. And even in what we've been able to accomplish, we're not as successful as Boston Dynamics. But the one thing that makes us better is that we're focusing on the cost question. We're not neglecting that. So I haven't actually answered the question, how much do I think robots will cost in the future? I'm going to try to keep these at 30 minutes, but we're already running over. So I might cut out the omnidirectional wheel discussion. We'll just finish up with this discussion and cut it from there, and we'll tackle that next week. Okay, so let's analyze this. What's anything worth at all? So a robot would be an investment. It's not something, it's not entertainment. It's not strictly an expense. It's not something you have to purchase. Now, it might be an expense in that you're trying to, you need a robot to get a job done. But it's an investment in the sense that you have a lot of different options. So, you might already be hiring employees to do a particular task, but maybe you could bring a robot in and do that same job and you could save money. Okay, so in that sense, it's a project with a return. So in everybody, whether they analyze it like that or not, that's essentially the decision they're making. Now, it'll be like it is with phones and computers today, where, there's, I might buy an iPhone, not necessarily because it's the best phone, but because there's a bit of pride in owning an Apple product. There's less so now, and it depends on who you're working with, but it's still the nicest, cleanest, best looking phone, and there's a bit of social status that comes with owning that over, say, an Android, and largely because it's more expensive. But so there'll be that kind of stuff in the future. But if an iPhone costs 10 grand, I'm not buying an iPhone for 10 grand. I'm really not even buying an iPhone for 1 grand. I had an iPhone 5S for years, and my dad got a new phone, and he gave me his old iPhone 6. So I'm happy to have my upgrade, but I'm not going to spend $1 grand on a phone. Maybe I will in the future, but not now. So there'll be a little bit of that with robots in the future, but it still has to be centered around some sort of logical investment decision, and especially for it to have a massive mainstream impact. So let's say you buy a robot. We'll stick with personal robots, something you're going to have in the house. You're not. That's an expense that you don't have right now. Is purchasing a robot. So you're doing chores at your house. You're probably still making your bed, although probably not every day. You're probably still vacuuming, although not every week. You're still cleaning the kitchen. You're still cooking. You might have some yard work you need to do, some different things you need to pick up around the house. You need to take out the trash. So you're not hiring a maid to do that. But if for the right price, you would in fact hire a maid. The reason you don't have a maid at your house is not because you don't want one, not because there's no value, economic or otherwise, productivity or otherwise, that a maid can bring to you personally, and your standard of living, and even how much work, like actual productive job work, you're able to get done. That can make a really big impact. You would have more time to invest in your career, have more time to invest in your family. This would be a valuable thing. People criticize. I have a tendency to go off on tangents, but I'll bring it back around. Don't worry. People criticize the idea of personal robots sometimes because, well, people will just be lazy. I agree. If people are just going to sit around, people are already sitting around a lot, and then you bring a personal robot in, they're just going to sit around even more. Yeah, it's not a good thing. It's not something that you want. My vision, though, is you have working people that are working really hard, that working a lot of hours a week. And then they have to go home and do even more work, and work even harder, and even get even more done. But you don't get paid for that section. So you're already working, we'll say 60 hours a week, but only 50 of those is for your job. So what a personal robot could do is it could take that 10 hours a week that you're spending on chores, and it could take that and put it into your career. So I don't think, my vision for personal robots is not that these come in so that we don't have to do anything. We can just kind of sit around. It's so that you can actually do more work, not less. But it's more of the value add work. I mean, like take like a lawyer, for example, making 150 grand, or a doctor, making 150 grand or something. They're making a lot of money. And if you live in the Midwest like us, my wife and I are looking at houses just for fun. And it's incredible how big of houses you can buy if you have a salary of like just 150 grand. I mean, you can, if you live out in California, 150 grand is buying a pretty small home. Out here, you're getting like a 5, 6, 7,000 square foot house. I mean, you can get a huge house for 150 grand. But that's not enough money to hire, a maid. Maybe you have somebody come in and help, but you're still having to do a ton of work. Maybe you're lucky and your spouse stays home and does the majority of that work. But even then, it's like your spouse could be doing more valuable things than cleaning and cooking and whether that's working with the kids, helping with something, or volunteering, getting a part-time job. They have their own passions that they could be pursuing that are outside of domestic chores at the house. So anyway, that's my defense of the personal robot concept. My whole point of this is that the doctor that still has to go home and do chores, we would be better off in a society where they didn't have to go home and do chores, but instead they could invest a little bit more time at the hospital or at the clinic or wherever they're working. So that's my defense of personal robots. So how much, though? So we've established that there is an economic value to having personal robots, and there's an economic value to having a maid, to having a butler. It's not just purely a luxury. Now, when you're spending, your 50, 60 grand that you might have to spend a year to hire a full-time butler, okay, that's a luxury. But there's a price at some point. Anytime there's some sort of economic return, there's a price at which that makes sense. So how we can establish how much robots will cost in the future, and the price we should aim for, should be established based upon how much return people can expect if they could hire a maid for $0 an hour. And we should take the net present value of those cash flows. It's really kind of intangible cash flows. And we should take the present value of those cash flows, and we should say, okay, let's say, for the sake of argument, it's worth the present value of having a maid for $0 an hour is $10,000. Well, if it's $10,000, then the price of our robot should be less than $10,000, because if it's less than $10,000, then that's a smart economic decision. Now, it has to be, it's always a good idea with projects like this, even though you insert a discount rate it's always a good idea to stay on the safe side. So technically, you should take on that project if you can make $1, and assuming it's a non-restrictive capital market. But so let's say the price should be $5,000 or $6,000, and then people all of a sudden look at that and go, okay, that's a really valuable product for me to have. So we can analyze this. Let me run some quick maths. So let's say you spend 10 hours a week doing chores, but we'll go on the low side. We'll undercut this a little bit. So let's say you spend 5 hours a week doing chores. If you had a personal robot butler, we could cut that down to 1. So the robot would save you 4 hours a week. Now, what's your time worth? We'll say your time is worth, it's going to vary a lot. GDP, I think, puts it at like $50 an hour. But again, to keep things conservative, we'll say 25. I'm just curious what the number is going to show up here. So 25. So we got 4 hours a week that we can save you at $25 an hour times 52 weeks in a year. So we're looking at saving, just with that 4 times 25 times 52, $5,200 of value that a personal butler could bring you every year. So year after year after year after year after year, you're getting $5,200 of value. These were very conservative. I mean, your time, most likely, if you're listening or watching to this, your time is worth a lot more than $25 an hour. My time, for instance, I can charge up to, if I want to do freelance IT work, I could charge up to $75 an hour, and it's, so that really changes the economics of personal robots tremendously, depending on where you're at. But if we're shooting for the mainstream, $15 to $25 an hour is a safe bet. You may not be making that today, so you might, let's say somebody's just starting off in their career, maybe they're making $15 or $20 an hour. But you've got to think of it over my career. What is my time worth today? So your time is worth, when you're early in your career, your time is actually worth more than you're getting paid, because you're gaining experience, you're learning new things, you're educating yourself, and that's most of the benefit of having a good job early in your career is not actually in the pay that you make, but it's actually in the experience you get that allows you to make more in the future. So that means that you're actually worth more than you are getting paid, or your time is worth more than you're getting paid by your employer, most likely. So $5,200 a year. Now, the way you would do this in finance is you would take that cash flow and then you would spread it out. You would say, what's the present value of $5,200 of cash flows every year? We'll say for the next 10 years. Maybe that's the lifespan of the robot. And then we're going to discount those cash flows at some sort of discount rate to account for risk, to account for depreciation, to account for maintenance costs, that kind of thing. So it'd use some discount rate. But with $5,200 a year, you could use a really aggressive discount rate and it would still make sense. Like our Tr2 is a $4,500 robot as the base price. And in this future, if it was able to take away 4 hours of your chores every week that you had to do, or you didn't have to do that, this would make sense economically for you to go out and purchase a Tr2, because look at how much value this can provide to you over the next decade. So that's how I think about the question. I've had talks with some people about this very thing, and there are some people that think that our price point is still too much. If the $4,000 to $5,000 range is still more than what people would pay, because there's not a lot of decisions that you're making financially that is a $4,000 or $5,000 decision if you're for you personally, right? My wife and I, for example, we're very conservative with our finances. We live in a house that's much smaller and much more affordable than we could afford. I've been driving the same car since I was 16. It has almost 265,000 miles on it. Still runs great, so I'm still going to drive it. I don't want to buy a new car. My wife's car is in better shape, but same deal there. A lot of our friends are going out and buying new cars. A lot of our friends are going out and buying, much bigger houses, much nicer houses. And that's something we look at, and that's something we get excited about, making those sort of decisions in the future and being able to splurge a little bit more. But so given that background, there's not a lot of decisions that we make that are in the $4,000 to $5,000 range. I mean, I make a lot of business decisions that are in that are in that upfront investment range, but personally, even appliances, you're unlikely to spend that much. You might spend it on like a renovation, like a house renovation. If you're redoing a kitchen or something like that, you might spend $5,000 to $10,000. But so that's why people hear the $4,000 to $5,000 price point, and it might be still shocking. I get two responses. I get people that are familiar with the industry and they go, "Oh my gosh, this thing is so cheap," and I get people who aren't as familiar with the industry and they go, "Oh my gosh, this thing's really expensive." So I never know who I'm talking to. But $4,000 to $5,000, fair price for a robot like this. It's not, I can't promise it's going to do that, be able to take away 4 hours of chores anytime soon. But that's what we can aim towards is, it can take away, it can take away one task that you do every week. Now it can take away 2 tasks, take away 5. Now you're saving, 2 hours a week. Now you're saving 4 hours a week. And at that point, you can really name your price because it's just that valuable to have in your house and a part of your household. And that's how I think about that question. It's a really interesting question. Not enough people are thinking about that in the industry, and people that are building these companies to try to do what we're doing. If you're not thinking about this question, then you're not thinking hard enough. So 47 minutes. Wow. Very good. This is great. I think I've only potentially said one offensive thing, which is really, really valuable. Yeah, I decided not to do these live for that very reason. Because, look, this isn't going to be like a PewDiePie, driving over the bridge live stream incident. But I don't know. I don't want to offend people, especially whenever I'm doing it through the company. Anyway, that's all beside the point. I hope this has been valuable. This has been interesting for people. The goal is one time every week. Monday or Tuesday, I'm going to come in and record a 30-minute podcast. I'm going to try to keep them more brief. Eventually, we'll maybe get to where we bring on guests. But I mentioned at the beginning of the podcast, I have to be honest about what I am able to do and what I'm able to commit myself to. I am not making a commitment that this will be every week. That is something I'm working towards. But I have a lot of other things that I do. I think this is a great opportunity for the business, great opportunity for potential customers to know a little bit about the company, a little bit about how I think about robots and why Slate Robotics is going to make it, right? And it's important that potential customers and existing customers believe that. But I'm not going to do this if there's no value that it brings. So this is really just a test. I'm just testing the waters. So hopefully this provides value to customers, provides value to me personally, to the business. And if it doesn't, I'll just stop making these podcasts. So again, no guarantees at this point what whether or not, I'll still be doing these, a week or 2 weeks or a month or 2 months from now. So all that's fairly tentative. But anyway, leave your questions, leave your comments in below, whether you're watching this YouTube, Facebook, whatever. Email me, zach@slaterobots.com. Visit our website, yada, yada. Thank you very much for watching, and I will see you all next time, hopefully.